All right, let's get right into it. Today, we're taking a trip out into the cosmic graveyard, because we're going to meet one of the most extreme, most violent, and frankly, one of the most fascinating objects in the entire universe.
You know, this quote it hits the nail on the head, doesn't it? We're talking about something so far beyond what we can imagine in our daily lives that it honestly feels like it's been ripped right out of a science fiction movie. This is an object that takes the laws of physics and just pushes them to their absolute limit.
And that object, of course, is the Neutron Star. So, in this explainer, we're going to break it all down. How are these cosmic monsters even born? What makes them so unbelievably strange? And, maybe most importantly, why are they so crucial for understanding, well, the universe itself?
Okay, so here's the crazy thing. The story of a neutron star, it doesn't really start with a birth. It starts with a death. And not just any death. We're talking about one of the most spectacular, most violent events the cosmos can possibly cook up.
So picture this. A massive star, way bigger than our sun, has been burning for millions of years. All that time, there's this perfect balancing act going on. The outward push of nuclear fusion fighting against the inward pull of gravity. But then, the fuel runs out. And when that happens, gravity wins, instantly. The core collapses, and that collapse triggers a supernova explosion so powerful it can outshine its entire galaxy for a little while. And when all that cosmic dust finally settles, what's left behind is the crushed, super dense heart of that dead star.
Now what's left behind? Well, it's an object with characteristics that are almost impossible to wrap your head around. It's really just a testament to the sheer, raw, crushing power of gravity.
I mean, just look at this comparison. It's absolutely staggering. You've got an object with more mass than our entire sun, but it's been squished down into a space that's no bigger than a city. Seriously, try to picture that. The scale of that collapse it's just mind-boggling.
Just let that sink in for a second. 20 kilometers. Everything that made up a star that was once millions of kilometers wide is now packed into a little sphere you could literally drive across in less than 30 minutes. It's this insane level of compression that leads to all of its bizarre, mind-bending properties.
And when I say mind-bending, I really mean it. The stuff inside a neutron star exists in a state of matter that we just can't create anywhere else. It's completely unique.
So besides the singularity of a black hole, this is it. This is the densest object in the known universe. Think about this for a second. The atoms that make up you, me, this desk, everything. They're mostly empty space. Over 99% empty space. Well, in a neutron star, all of that empty space has been completely crushed out of existence. And this analogy is just perfect for trying to grasp what that means. If you could somehow scoop out a sugar cube's worth of this stuff, it would weigh 100 million tons. That's like an entire mountain packed into a sugar cube. It's a scale of density that our brains just aren't built to handle.
So you might be asking, why doesn't it just keep collapsing and become a black hole? Great question. The answer is something called neutron degeneracy pressure. It's a fundamental rule from quantum mechanics. Basically, you've squeezed these neutrons so tightly together that they physically can't get any closer. They're pushing back, saying, nope, no more room. And that push is the only thing stopping this thing from collapsing completely.
Now, all that incredible density creates, you guessed it, an equally incredible gravitational field. We're talking about a force so powerful, it literally warps the fabric of space-time around it. You could see the distortion if you were close enough, which you wouldn't want to be.
And here's another wild consequence of that gravity. The surface of a neutron star is almost perfectly smooth. Why? Because the gravity is so immense that if you had anything you could call a mountain, it would be instantly crushed down to just a few millimeters high. That's it.
And if all that wasn't crazy enough for you, they spin at absolutely insane speeds. You know how an ice skater pulls their arms in to spin faster? It's the same principle, just on a cosmic scale. A star that might have taken weeks to do one rotation collapses down, and suddenly it's spinning hundreds of times every single second. It's incredible.
But wait, there's more. All these extreme properties, the density, the gravity, the spin, they combine to create even stranger things. They turn these neutron stars into some of the most exotic objects we've ever found out there. First up, we've got the Pulsar. This is what happens when you take that crazy fast spin and you combine it with a super powerful magnetic field. The neutron star basically becomes a cosmic lighthouse, sweeping these intense beams of energy across the galaxy.
Here's how it works. The star's magnetic field is so intense, it acts like a giant funnel, right? It channels these powerful beams of radiation out from its magnetic poles. And because the star is spinning so fast, these beams just sweep across the cosmos like a lighthouse beam. If one of those beams happens to swing past Earth, our telescopes see a pulse of energy, and it's incredibly regular, like perfect clockwork.
But sometimes things get even more extreme. Yeah, it's possible. Meet the Magnetar. This is a special kind of neutron star with a magnetic field so unbelievably powerful, it defies comprehension. It is, without any doubt, the deadliest and most powerful magnet in the entire known universe.
Yeah, this chart pretty much says it all. We're not talking a little bit stronger than Earth's magnetic field. We're talking quadrillions of times stronger. It's so intense that if you were even thousands of miles away from one, it would kill you. It would literally rip the electrons right out of the atoms in your body. Terrifying.
So, okay, they're terrifyingly powerful, but why should we care? What's the point of studying these cosmic monsters? Well, it's because they are one of the greatest gifts to science that the universe has ever given us.
At the end of the day, neutron stars are basically nature's own high-energy physics labs. They let us see what happens to matter under conditions that are so extreme we can never, ever hope to create them here on Earth. They're the ultimate stress test for our biggest ideas about the universe, pushing theories like general relativity right to the very edge.
They're just this powerful reminder that even in death, a star can create something absolutely extraordinary. And it really makes you wonder, doesn't it? If this is what a dead star can do, what else is hiding out there in the cosmos? What other impossible things are waiting for us in